So this video will show how to appropriately design an application that accesses a database, how to structure it in layers and so on. So in this video I'm assuming you already watched first this video with the introduction to JDBC, the API to call databases from a Java program. And I'm also assuming you've already watched this video, which gives some basic introduction to architecture and design. So I will not explain in detail the MVC and the layer patterns. But before we go into this application and how it's designed, let's first see what it actually does. So it's some kind of very simple bank application. Let's run it. So we can list the commands. These are the commands. List without parameter lists all accounts in the bank, and I've already ran it before, so there are already some accounts that I've created. Here are these accounts. We can also list the accounts for a particular account holder, for example, Stina's account. Here they are. We can create new accounts, a new account for the holder Ulle, for example. Now we see that there is one more account. Which one? Here Ulle had only one account. Here there are two accounts for Ulle, so there has been one new created. This is the account number, and it exists also here. So this is the newly created account for Ulle. Right. What more? We can deposit to this account number. Let's say we deposit 10, and then we can check the balance of the same account. Now 10, before it was 0, and now it's 10. So before it was 0, now it's 10. Makes sense. Yeah, we can also delete an account and what more, withdraw from an account. But that's enough. You get the idea of the application. The very simple bank application. Right. So now let's have a look at the application. So first, I will very briefly tell which layers there are without repeating everything about the MVC and layer patterns. Okay, but the MVC pattern tells us to use a model, a view, and a controller. And then in this particular application, there is also a database. So this barrel over here is the database server. And the layer pattern tells us to introduce a new layer if we access an external system like a database. And this new layer can be called integration, which is its name in this application. And the integration is responsible for calling the database. Okay, then there's we have two options here. Who is to call the integration layer? It could be the model or it could be the controller. It could of course also be both, but that would not be a good idea, since then we would be mixing two styles. It's better to be consistent, and perhaps the most common solution, which is used here anyway, is to let the controller call the integration layer. Right, so there are two units here which are should not be broken. One is that consists of the controller and the model, and the other of the integration layer and the database. So the very purpose of the controller is to know all the details of the model and call the appropriate objects in the model. So the only way to enter into the model is via the public methods of the controller. And that's, of course, also the only way to enter the controller. And the only way to enter the integration layer and to call the database is through the public methods of the integration layer. So this thick black things now represents the public methods of that layer, which is the public interface of those layers. So in particular, let's look at the integration layer. Which is the purpose of this application, to illustrate the integration layer. So the public interface of the integration layer shall be adapted to the controller if the model, well, it shall be adapted to the needs of the layer calling the integration layer. In this case, that is the controller. So we create public methods in the integration layer that meet the needs of the controller. And inside, in the internals of the integration layer, we hide all the SQL statements and the messy details of the database calls, and that will not be visible outside the integration layer. So let's take a closer look at the integration layer. So inside the integration layer, we have classes called DAOs, which means Database Access Object, which is a common name a name that is commonly used for such objects. And the purpose of the database access object is to handle access to the database. The database access object is called the database. So this quite small application has just one DAO. It's called the bank DAO. In a bigger application, we would have to split the DAO into multiple DAOs in order to not make them too messy, to maintain high cohesion in the DAOs. Okay, but the public interface of the DAO, as I was saying previously, is adapted to the needs of the classes calling the DAO integration layer, which in this case is the controller. So here is the controller class. And it calls the DAO. Right, so say for example that the controller has the need to find an account with a particular account number, then we create a public method in the bank DAO that is called find account by account number. And it should of course take the account number as parameter. So that exactly meets the needs of the controller. And now the code in the controller will be very simple. It will just say when we need to find the account with an account number, there will just be a call to the method find account by account number, passing the account number as parameter, and it's very obvious what that method does and what happens in the controller. So the code, this way of organizing the integration layer and the DAOs makes the code outside the integration layer very easy to read. That's the good thing. The maybe not bad thing, but a bit worse thing is that inside the DAO, we just have to place whatever code is needed to meet the needs of these methods that we are forced to create by the requirements of the controller. And so we hide all the SQL statements and whatever details regarding database calls are needed inside the DAO. Right, so now let's look at this in the code. Okay, so here is the bank DAO, and actually related to JDBC, there's very little new here that wasn't already introduced in the basic JDBC program and the video introducing JDBC. There are a few things which I will soon explain, but first let's have a look at how the public methods are adapted to the needs of the controller and how the messy details of the SQL calls are hidden inside this bank DAO. So here we can see that the public methods are create account with a particular account number. Okay, so I will soon explain what account DTU is, but it's basically there it's an object that wraps all the details, like for example the account number and the account holder. So create this and an object to delete an account, and this string here is actually the account number. Find an account by account number, as we were discussing just previously, specifying the account number. Find accounts by holder, specifying the holder, and find all accounts without parameter, just list all accounts. Find the primary key of an holder by specifying the holder's name, and change the status of an account. Update an account that exists in the database to have the state reflected here in this object. Okay, so those are the public methods, and as we understand, they are exactly what is needed. Well, maybe it's not obvious, but we'll soon see that it's the case, that they are exactly what's needed by the controller. And when soon we look at the controller, we'll see that these are the exact needs of the controller. Actually, why not look at the controller right away and see that this is the case before going into the details of the DAO. So looking at the controller, we see that there's very little code in the controller, which in big part is due to the fact that we have a DAO which contains exactly the methods needed by the controller. Okay, so when the controller is started, it creates an instance of the bank DAO, which is the bankDB object stored in the bankDB field and is later used. So, for example, in the method create account, we just call the create account method, passing an account object, and that's all that's needed to make the database create a new account. And then we have a method list all accounts, which lists all existing accounts in the bank. There was such a command in the user interface, so we need such a method in the controller. Remember that the controller has one method per system operation. That is one method per thing the user wants to do. And then it just calls the find all accounts methods in the bankDB. So that method, find all accounts, for example, was written because here there was the need for that operation in the controller. Right, then we have, for example, here, get accounts for holder, which returns all accounts for this particular account holder. And it just calls the find accounts by holder. And so on. So you can see that the methods in the bank DAO were created to meet the needs of the controller. Okay, now let's have a look at some details of the bank DAO. So the basics are the same, I would say, as the basic JDBC program explained in the video introducing JDBC. We create connection to the bank and create prepared statements. We execute the prepared statements and so on. Some things that are different here or new are first, the database is not created. I mean, the tables are not created by this DAO or by the program, we could say. Tables are not created programmatically, but must be created before. And that is how it should be. A bank application should not create the database every time it started, or even have to check if the database exists. The database is a very complex thing which is created by a database manager using some kind of administrative interface to the database server. It's not that we create the database programmatically every time the program is started. So that's one thing that's different here. So another thing that's different here is the transaction handling. So by default, JDBC has auto-commit true, which means that whenever an SQL statement is sent to the database, it's wrapped in a transaction. The transaction starts when the SQL statement is sent and commits as soon as the SQL statement is completed. But that is not the case here. Looking at the connect to bankDB method, we see that we set immediately when we have created the connection, the same way as it was created in the basic JDBC program, we set auto commit to false, which means that we manually have to commit or roll back all transactions. There's no operation called begin to start a transaction in JDBC. A transaction starts immediately, automatically, when an SQL statement is executed and there is no current transaction existing. Why do we set auto commit to false? Well, it's because there might be the need to send multiple SQL statements in the same command, in the same transaction, I mean. And that is the case here in create account. So in create account, right, now I realize I have not explained the database structure, but the database structure is obvious from the script creating it. So this is the script used to create the database. There's one for Postgres and one for MySQL. And here we see that the database consists of two tables, namely holder and account. Right, so a holder can have multiple accounts. There's a one-to-many relation there. Okay, I will not go through the details of the database. There's nothing particularly interesting there. Only things we talked about before. Right, so when we create an account, we have to create both a holder and an account. That is, if that holder does not exist yet. So we pass in this object here, which contains both holder and balance. All right, and then first, so remember that the transaction will automatically start when a new SQL statement is sent. So first, we check if there is this holder, and there was the need to have the method find holder primary key by name. So call that with the specified holder name. And that method is here, and okay, we see that it issues the find holder primary key statement, searching for the primary key of that holder in the database. If there was such an entry, such a holder, it returns the primary key, otherwise it returns 0. Right, so then we received the holder primary key, and if it was 0, there was no such holder in the database, and then we have to create the holder. That's what happens here. And then when it's created, there surely is such a holder, and then we can retrieve the holder's primary key. So now we have the holder's primary key, and then we can create the account, which happens down here. And the holder's primary key is stored as foreign key in the account table. Okay, but here we see that multiple SQL statements were executed in order to fulfill this operation to create an account. It started already here. Well, maybe it's better to say here in the call to find holder primary key by name when searching for the holder. Then maybe the holder was created here, and if so, the primary key was the newly created primary key was retrieved there, and then there is the call here to create account. So there were either 2 or 4, depending on whether we had to create the holder or not. Either 2 or 4 SQL statements executed here, and of course they should all execute in the same transaction. If we fail to create the account, we should also not create the holder. Remember that a transaction must be atomic. Either everything is done or nothing is done. Okay, and then finally we commit the transaction and save the database, the updates made during that transaction. If the transaction fails, if there is some kind of SQL exception, some error in the database calls, then we come here and we call the method handle exception. And here in the method handle exception, we see that the transaction is rolled back. So if an exception is thrown, there was obviously some failure, and then we have to roll back the transaction. Right, so that was transactions. So what more is different here compared to the basic JDBC program? So we could have a look at the fact that we have to close result sets. And let's see here. Find account by account number, where we search for the account with a particular account number. So the account number is specified, and we set the parameter in this prepared statement, and we execute that prepared statement, and then we get the result set. So all this is similar to the basic JDBC program, but I want to emphasize the fact that we have to close this result set. So here is the result set. It's returned by JDBC when the statement is executed here. And then remember that a finally block is always executed, no matter what happens inside the method. When there is a try with a finally, we never leave the try without executing also the finally. And it doesn't matter if an exception is thrown or whatever, we always execute the finally. And in the finally, we close the result set. And here in close result set, well, we close the result set. Nothing strange about that, but it's important to actually close the result set, because only when the result set is closed are the locks released in the database. The driver will, the database will keep the locks until the result set is closed. Okay, so another thing that is different here in this application from the basic JDBC is that the line class.4name, loading the driver, is missing here when the driver is loaded, when the connection is created. And that is because starting from JDBC 4, I'm not sure which JDK this is, but anyway, now we are above JDBC 4, that line is no longer needed. So actually, I'm not sure how the driver informs the driver manager of its existence. Maybe the JDK does class path scanning, which is quite common, loads all drivers that it finds on the class path. That could be one way to solve it, but I'm actually not sure how they do it. But we don't need the class.for name line anymore anyway. Okay, I think that's all of importance in the bank DAO. There's a lot of code, but the rest is just more of the same kind, so to say. Okay, now we've seen the database specific things in the program, and that means we're kind of done. But I think I will also go through quite briefly what happens when the program is started and follow one command from the user interface all the way down to the database. That way, it will make it a bit easier to understand the code, perhaps. So let's start in main when the program is started. So we first create an instance of the blocking interpreter, which is the command line interpreter, and we send it an instance of the controller. It will call this controller, and then we call the method handle commands in the blocking interpreter, which actually starts the interpreter and makes it interpret commands from the command line. So let's look at the blocking interpreter. So here it is, the blocking interpreter. The constructor does nothing but to save the controller that was passed, and then we call the handle commands. So here in the handle commands, we stay in an eternal loop while keep receiving commands is true, and it is true until the user types quit or until the method stop is called, but it is not called in this program. But what happens in the handle commands loop? So as I said, we loop until the user types quit when the keep receiving commands is set to false, and the execution will exit the loop, and this method will terminate, and then the whole program will terminate. Remember, this method was called from main. So actually this method blocks. It does not return until the command line interface is shut down by the user typing quit, and the program exits. That's why it's called blocking interpreter, because it blocks this thread. And you can also see that while it's executing, it can just do one thing at a time. So while it's executing one command, it receives some instruction from the user, calls the controller, and then while that happens, until the controller has called the database and it has returned, the command line interface is blocked. So while one command is being executed, the user can do nothing. For example, if the database, for some reason, now I have the database server on the same laptop, and it's of course quite fast. Say that we had to make a network call to the database, and for some strange reason this network call was very slow, or we sent a very huge query that took a long time. You can argue that then the program is not well designed. Might be the case, but anyway, if the system is for some reason slow to execute a command given by the user, then the command line interface is blocked while that command is being executed. The user cannot, for example, give up and quit the application. And that's, of course, not very good. So a user interface should not be blocking, but the focus of this course is neither on using threads nor on user interfaces. So I've just kept it simple and written a blocking interpreter here. Okay, now let's see what happens when the user gives some particular command. Let's choose deposit, because there are some interesting details in deposit and withdraw. So if the user has typed deposit, the deposit method in the controller is called. And this command line thing here, this object is just to extract parameters to reduce give higher cohesion and not have complicated code parsing strings here. So the string parsing and the parameter extraction is in the command line class. Right, but the first parameter is the account number, and the second parameter is the amount to deposit. And then the deposit method is called with those parameters, account number and amount. And then first, it's a very good practice to check the parameters before doing any operation. So not just to start and hope for the best. So we check if the account number is null before we do something and create and run into an exception, null pointer exception or whatever, because of the account being null. Right, so we check if the account is null. If so, throws an exception telling that the deposit could not be performed. But if the account is not null, we continue here to the find of account by account number method in the DAO, passing in the account number. And, well, nothing strange, just plain database calls. Set this parameter in the prepared statement, execute that prepared statement, extract the result, commit the transaction, close the result set, and return the new account. And remember that even though there's a return statement here, the finally block is still executed. So if everything goes well here, the execution is like this, comes to return, then the finally block, and then return. Right, so the found account was returned. Here's this one thing worth emphasizing. So note that we return an object. Here's an account object, and we return this object here. We do not return like some table-like structure or some primitive values or whatever, but the public interface, the public methods of this DAO should be object-oriented, and we return an object representing the DAO. That's important. Okay, we're back in the controller. We found the object, it's here, and then we call deposit in the amount, in the account, passing in the amount to deposit. So this is the account object that was created by the DAO, and it has the method deposit. So this is actually the model, and it was created by the DAO. And here we have called the method deposit. Then we, as I said previously, check the parameters before doing any work. It's not allowed. We are not allowed. This bank has a business rule saying no negative amounts can be deposited. Makes sense, I think. Okay, so if amount is less than 0, then throw this exception, and then update the balance. This is where the actual depositing takes place. Okay, back to the controller. So now this account object has the higher amount after the deposit. Then we have to store that new state of the account in the database. And that is why the update account method is called here. And, well, nothing much strange here. The update account actually just updates the balance. Set the parameter, the new balance for the account of this account number, and then execute that statement. And now the bank account is updated. If there was not one updated row in the database, then handle exception, which will roll back the transaction and throw an exception. Right. So back to the controller again. Okay, a few words about transactions, maybe. Yeah, that's interesting. So what about the fact that all SQL statements must be wrapped in the same transaction? Is that really the case here? So what happens here? No, that's not the case here. But we can see that we're fine anyway. So what happens here is first that a transaction is started. So here there is the case that a transaction is always committed or rolled back before the bank DAO method returns. So a transaction is first started here. Let's say call it T1 start. Well, it started inside the find account by DAO find account by account number method. And it commits when that method returns. T1 commit. Assuming everything went well. If it rollbacks, then the bank DAO will also throw an exception. So the bank DAO always combines rolling back transactions and throwing exceptions. Never just one of those two events, always both together or none of them. And if it was rolled back, then the exception was thrown, and we stop executing here. Go to the catch block and then return. So then we have tried to execute one SQL statement. It was rolled back and nothing more happened. So then we're fine. But if it's okay, if it committed as I've written here. Then we continue executing, update the balance of this account object, and eventually call update account. And here we start another transaction. Let's call it T2. Then that transaction should commit after this update account method. T2 commit. Okay, if it commits, fine, everything went well. But what if there's a problem here? If it rolls back instead, not commit, but roll back, then it seems like we have a problem, because then T1 was successfully executed and was committed, but T2 was rolled back. Not good. Only half the operation was done. But the situation here is that this first find account by account number just reads. It did not update any state. And this, here there was an updated state in the account object, but that account object is lost. See, it was created here. It is a local variable in this method. So when the method returns here, that account object is discarded and its state is never stored in the database. So if this one succeeds and commits, and this one fails and rolls back, all that's happened in the database was that a read was made, and that did not change any state of the database. So we're fine. Even if the second transaction is rolled back and the first one is committed, it is as if nothing in this method had ever started, because only read operations have been performed. It could have been worse. Say, for example, that we had the method transfer that should transfer money from one bank account to another. Then we could not have solved it this relatively easy way, because then we would have first withdrawn. We would have two read operations. Two write operations in that case. One that lowers the balance of the from account and one that increases the balance of the to account. And then both those would have to either commit or roll back. So then we could not have the design we have here, that one method in the bank DAO is one transaction. Then we would have to leave the transaction running when we return from the bank DAO, or make some kind of compensating transaction that restored the state in the bank DAO if the withdrawal succeeded and the deposit failed. But that would be quite messy. I think it would be probably be better to do both withdraw from one account and deposit to the other in the same transaction. Okay, but here we get away with this solution. Right, so all that's left now is this DTO thing. So let's look at the DTO. So before we look at the DTO, we have to look at the account. Here we see that the account has typical methods for a bank account: deposit, withdraw, get the balance, and also some other getters to get the account number and get the holder name, and the toString method. Typical bank account methods, we could say, but what is interesting here is that it has both methods that update the state, which are withdraw and deposit, and it has read-only methods, which are the rest. Nothing strange with that, but so the thing is that this account object has to be returned from the controller to the view, because the view, for example, in the list methods, gets a list of accounts which are displayed to the user. And what if we had returned the account object to the user interface? Remember, the view should not perform any business logic. This is essential, the very purpose of the MVC pattern, to avoid business logic like deposit and withdraw being performed in the view. That is the task of the model. And if we had returned the account to the view would be free to call deposit or withdraw. Of course, we could say to the programmer creating the view, never call deposit and withdraw. But it would be hard for the programmer to remember that programmers are very fallible humans, right? Like everyone else. So, of course, the programmer would sooner or later make the mistake and accidentally call deposit or withdraw in the view, thus breaking the MVC pattern. So therefore, we have to stop such errors happening, help the programmer creating the view not to accidentally call deposit or withdraw and update the state of the account performing business logic in the view. And in order to do this, we have created a read-only view of the account, and that is the account DTO. So the account has all these methods, including the write methods, deposit and withdraw, but the account implements the account DTO interface. And the account DTO interface has only read methods, the getters. So while the view actually gets a list of accounts back, it sees those accounts as instances of the interface type account DTO, and also here in the balance command. So that means in this object, ACCT, only the getters can be called, and there's not the risk of accidentally calling deposit or withdraw. If here we try to call deposit, deposit 10, well, there's a compiler error. There is no such method in the interface type. It's actually in the class account. Of course, we could claim here, well, it's just all you have to do is to cast this thing to account. And now we're fine. This proves that we could bypass the account DTO idea. And of course that's true, but the purpose of creating such an account DTO was never like to stop attacks. It's just, or it was not meant to be 100% foolproof. The whole idea is to help the programmer creating the view not to make the mistake. And we have certainly done that by forcing the program to cast the account DTO object into an account object in order to be able to call deposit or withdraw. So we've given some assistance to the view programmer. It's not 100% sure, no, okay, but it's some help, right? And so last thing, what does DTO mean? So DTO means data transfer object, and it is an object containing read-only methods, only read methods, that is used to pass data between layers, in this case between controller and view and integration. And there are a lot of ways to create such DTOs. This method of creating an interface that was used here is just one way. There are many other ways. Okay, but this is really a bit outside. Well, it's not entirely outside the course, because you have to handle this problem in order to make a well-designed and appropriately layered program. But more particularities of the DTO pattern is certainly outside the course. So I'll just stop here. And with that, we have covered everything of this application. Okay, so this illustrated how to create a reasonably well-designed program accessing a database.